Ugh. Ugh. Okay. Hello everyone to another evening of Dan Does Data. Tonight we're going to be looking at another piece of software, PyTorch. You might have heard of Torch already. That's a machine learning framework that's been out for a long time. I believe is big at Facebook. I haven't actually used it because my understanding of Torch is that it's written in Lua, I think, or it's written for Lua. And I haven't bothered to learn Lua because I already know other scripting languages. So the marginal utility of that is just not as high for me. Torch web browser, Torch scientific computing for Lua JIT. Yeah. So I think I might have looked at it once, thought about it. I know other people who are into it. But I could not be bothered to learn another scripting language just to try this library. Thankfully, hey, someone came out with, or perhaps the makers of this came out with Python bindings for Torch. So now it's no extra work for me. Now it's just another library. So yes, they stress they're an early release beta, so expect some adventures. I feel like that's a good motto. Expect some adventures. So I haven't done anything yet. I haven't installed it. Nothing. We're going to start from the basics, and if they have a tutorial, we're going to just kind of work through that and see what we like. I've done this for TensorFlow. I've done this for Theano and Keras. It usually works pretty well. One thing, and they're at pytorch.org. I'm running an Ubuntu system with a very modest graphics card. And one thing I love, they show you right away how to install it. And depending what your setup is, they show you the different ways to install it. This is absolutely beautiful. I also love that if you click, I want to install it from source, they say, hey, just go to this website. That's more than a couple lines. So I'm on a Linux system. I like to use pip as my package manager. I'm on Python 3. I happen to know I'm running CUDA 7.5. You can use nvcc -- version to get your compiler version of CUDA. The compiler version and the toolkit version should be the same. So this is what I need. Linux pip 3.5 and CUDA 7.5. So they say, hey, pip install this, and then pip install Torch Vision. So that works for me. I'll be using pip 3 because I have Python 2 and Python 3 on my machine, and I don't want to go crazy. So let me just do that right away. Pip 3. There we go. Let's see how this goes. Oh my goodness. That seems incorrect. Seems like an incorrect use of TQDM, like they're trying to print something out while TQDM is running. So I can tell this looks like the TQDM progress bar. And they're trying to print it out while it's going. Not a big deal. That's just downloading. Looks like a couple hundred megabytes is what it's going to end up being. It's 25% and 80, so yeah. This will take just another minute. So in the meantime, we're going to decide what the heck we want to do with that. We also need to remember to install Torch Vision when we're done with that. So not get started, learn more. Sure, I want to learn more about it. Python package provides 2 high-level features. Tensor computation library NumPy with strong GPU acceleration, and deep learning library that's built on a tape-based Autograd system. Tape-based Autograd I am not familiar with. I mean auto gradient, so like an automatic differentiation, which is critical. Visually computes derivatives of NumPy code. Oh, that's kind of cool. All right, so that's how they're doing their differentiation. So you don't have to compute the gradient yourself. That's automatically done based on whatever graph structure you have. Tensor library like NumPy. So far this is sounding very similar to TensorFlow or Theano or something like that. Placement for NumPy to use the power of GPUs. Oh, that'd be interesting. I hadn't thought of just doing that. I've used these kind of libraries exclusively to do like deep learning kind of research. But I could just use it instead of NumPy to compute a bunch of stuff on the GPU. You might also use PyCUDA to have a little more direct control. That's an interesting idea though. I'm gonna have to think about this more. That's just a good thing to remember. If I can describe my computation as a graph, I don't have to fit, I just have to compute it. I need to remember that. Okay. I almost forgot. Pip install Torch Vision. Bing, there it goes. Cool. sudo pip3 install Torch Vision. That shouldn't take long at all. Okay. And we should be able to test it very easily here. So that explains about what it is. So it's got this automatic differentiation, it's got some neural network stuff, got various optimizers, Python multiprocessing, but with magical memory sharing of Torch. Anytime you see the word magical in a library's description, that comes with a certain amount of risk. If something is magic, that's danger. There's another Python library, totally unrelated, called Cloud Pickle, that essentially pickles Python functions, which you normally can't do. It's been described as magic. I've done that myself, and it's a nightmare. Torch utils and Torch legacy. They already have legacy code. Interesting. Wonder how long they've been working on this. Okay, so yes, they talk about they're GPU ready. They're good with deep learning. They have some stuff right here. Back propagation is automatic. Yep, typical type of stuff. And it's Python first. Oh, is not a Python binding into a monolithic C++ framework. It's built to be deeply integrated Python. You can naturally yada yada yada. All right, well that's interesting. So there is no C++ framework then, I take it? All right, intuitive, linear. Well, linear in thought and easy to use. That's good if your graph is linear. If your graph isn't so linear, like not sequential, that could be trouble. I apologize if anyone's been in the chat. I have not had that window open. Let me do that. All right, what else we got here? Wait, a graph is created on the fly. That's interesting. Fast and lean. I like this idea. Minimal framework overhead. I like that. I'm a fan of that. So it's a bunch of code that's written in essentially C99. I like that. Code with minimal dependencies is good things. But I appreciate that they can use these maximum speed. Been tested for years. Oh, they are mature. Yes, those backends are. Memory usage is efficient compared to Torch. That's interesting. Custom memory allocators for the GPU. Oh, geez. That sounds like a pain. Writing neural network modules, interfacing. Favorite NumPy-based library such as SciPy. Oh, cool. If you want to write your layers in C++, so they do have an extension API, so you can write those kind of things. That's cool. Docs, I guess? I was hoping they would just have a little walkthrough kind of thing I could work through. That's always fun. I mean, yes, I can whip up my own kind of thing, but then I'm going to be blundering through a lot of things. Deep learning with PyTorch. I am Trask. So here's some fellow who apparently looked at this just a week or so ago. PyTorch installation, we did that. I don't really, sure, we'll poke around at that too. Yes. Installation. Was this just Torch? No. Surely you don't need to install regular Torch anymore. Import PyTorch. Okay, that's the magic I needed to know. So, try PT, we'll call it. We're trying PyTorch. Import PyTorch. I don't like the capitalized style. That's just a personal thing though. No module name PyTorch. Okay. So apparently that's not true. This is something else. That's like a Python extension of the Lua interface, I think. Is it just called Torch? Import Torch? Import Torch. Yeah, okay. Well, that makes more sense anyway. Import Torch. Ding. Perfect. I could steal my, self-driving car code. Although it takes a little time, and that's not an example that most people are familiar with. Like the MNIST, everyone's familiar with that. That works great, yeah. Do I have a Keras directory here? I don't think I do. No, I don't. Theano, nope. TensorFlow. I might not actually have a copy of this. Oh, I do have MNIST data. Okay. Maybe we can get away with this. Bing. Ah, okay, so I have some MNIST data lying around, waiting to be used. Just in a slightly inconvenient format. So I tell you what, let's see if I can convert some TensorFlow code to PyTorch. Tab new, Proj, TensorFlow. I don't even know what this code looks like. I haven't looked at this code in a long, long time. Oh, and that just comes with like a read datasets. I do not know if this will come with that. Let's find out. Torch vision. I don't really need the torch vision reference. Torch.utils.data. Tensor dataset. This is all like good and generic. Import it from Keras. Oh, the data? Yeah, I have the data. Oh, you're saying the Keras files are a little less painful to deal with? I'll tell you what, let's nuke that. Let's, just import Keras on the side here. I think there's a Keras dot, so we're running multiple, this could be really bad, running multiple backends at the same time. I might have to nuke this IPython session later. Keras dot, I'm surprised it didn't say using Theano backend. Well, that's just a Keras thing. So, unless I missed an obvious, that's Autograd mechanics, which is nice. Tutorial, no? Did they talk about MNIST here? It's kind of thing like, yes, I could parse through that, and it's not that hard to do, but that's not interesting to do on the stream at all. That doesn't show people anything new. Discuss, support. GitHub issues, newsletter, discuss. Maybe that's what we want. Can we search in here? Tutorial. Tutorial for deploying a cloud-based input preparation, roadmap. These are all in the last 6 days or so. Understand how this works, how to do backward. It's not really what I wanted. Okay. So how does Keras do this? I guess I could literally use Keras to like read in my data. That seems so cheap. Let's do it. We're doing it. We're gonna do it. Because I'm a bad person. Okay. I don't care. I'm a terrible person. From Keras import Keras.datasets. Yeah. So this part, don't ignore the man behind the curtain. Perhaps I should have had this ready to go already. Cannot import name because it's MNIST. Ding. There we go. So I don't want that anymore. Then, yes, I just want this. This is going to be a big pain in the butt. MNIST. Can I give it a... Oh, that's you're supposed to have a pickle. Ugh, I don't have a pickle. If path that ends with GZ, open it up, do this stuff. Yeah, that's not gonna fly. Oh, I guess it is. Oh, it knows the down. Oh, get file. I see. Well, I appreciate that. That didn't take long at all. All right. That is not. Oh, that might be correct. Matplotlib. No, import matplotlib. It's PLT. There we go. Let's do that. There's no attribute. .pyplot. One of these days, I will get this correct the first time. There we go. And we'll say plot dot, not image show, mat show x train of 0. First data point. Yes, okay, that's a digit. So everything's fine. Everything's fine, we're all fine here. We have data now, it's all good. So the question is, what are the torch, what's the syntax for this torch stuff? That's why I really wanted this tutorial, because that's the quickest way to understand the syntax. The docs I'm sure, are a wonderful, wonderful reference. This page, however, does not go down any further than this. Ah, explore, tutorials. Why doesn't this come up when I search this stuff? It's all on the GitHub page. Okay, I retract some of my complaints. Deep learning with PyTorch. That seems like a reasonable thing to check out. 60-minute blitz. You know, I feel like I looked at this the other day, and I did not remember that I looked at this. Train small networks, classify image, understand PyTorch, all this other stuff. Yes, okay. Make sure you have the torch and torch vision. So I have torch and torch vision, yes. I don't need to import future because I already have what I need. Okay, so you can make some simple objects, apparently. I don't need this anymore. Let's do this. Bing. And that gives you this fancy object. Oh, and you get to see the value by default. That's super cool. What if I just do this? So there's some kind of tensor object. Can I do this? What if I import Numpy as NP? You can't. You don't inherently get it. What things do you get with X? Oh, lots of things. So X, they're just making a tensor, which is basically a 5x3 matrix, a 5x3 doubly indexed array, multi-dimensional array, whatever you want to call it. Whatever all the cool kids are calling it these days. You get Bernoulli you can do? So, oh, you get all the different kinds of functions that you can do to these things. Alright. What is that? What is x.CUDA? What is this? Bound method of, what is that? Turns a copy of this object in CUDA memory. Oh, okay. Probably I will not have to worry about that. So it automatically like initializes it to something random. It says uninitialized, but to me that really looks like it's been initialized. So do this. Are X and Y different? Yeah, they are. And what's in Y? Let's change this to rand. So make a random array. I presume values between 0 and 1? Yes! Alright. I guess this is what's ever sitting in memory, which are just very small numbers that it interprets as very small floats. Son of a gun. Get all these little big 64 turds lying around. Okay. So that's cool. I really appreciate that I can just like print these things and get information about what's inside right now. That is nice. And that is sort of initialized by default. Ooh, size. Size is a thing? Interesting. Okay, that's fair. I'm a little irritated that it's not shape. Yeah, because that's what it is in Numpy. Whereas size is... Oh, and it's a special size object. X.size of 0? Okay, good. But I can just index into that. What's x of 0? Sweeten it. Wait. Yes. This is a single row. Because it's 0, 0, something else. Can I just ask for a specific thing? I can. Can I do this? You can. This is super nice. I dig that you still get the same NumPy-like syntax of slicing and array notation. That's very cool. I don't remember if TensorFlow has that kind of niceness. Probably it does, but it doesn't have this level of interactive feel to it. So I'm a fan of that. I like that. Hey, I already did that. What do you know? Addition. Yes, of course you can do addition. Of course you can do x plus y, and you get the value back out. And I bet I can even say z equals x plus y. Something like that. And then I get z. And z's some numbers, sure. Oh, or you can say torch.add. Not surprising, again. I'm running out of letters at the end of the alphabet. Torch dot... Can I torch dot, like, subtract or something? There's torch dot add, sure. There's no torch dot subtract. There's like torch dot minus? Torch dot min. Weird. I guess you just have to take -1 times something. Well, let's see what happens. Add x and -y. So w and z. All right. I guess that's just how you do it. Works for me, man. Works for me. You can result equals this, torch.add xy out equals result. Oh, so you can pre-allocate space and then stuff the result in there. So that can be very useful. So what is this doing? This is just initializing another empty array, and it's going to have whatever garbage it's going to have in there. So, and it's the same kind of thing, garbage, mostly zeros, just a handful of bits that are set. Woo! And then you can add those things together and say, hey, put this into the out. And you still get to see it, which is nice. And so that's the same as the result. That's neat. I kind of like that. Cool stuff. You can add in place. Alright, but can I just say y plus equals stuff? Can I say that? Can I say y plus equals x? Ah! Oh, that doesn't really... Tell you what, let's make another random array. Y2. So I got y and I got y2. Son of a gun. There we go. You know what? We're going to do this. We're going to come down here and make a new thing. Make this y1. And so we look at y1, we look at y2. And I say y1 plus equals y2. And now y1 looks like that. Neat. And if I say y1 minus y2, I should get back the original y1. Which looks correct just looking at these bottom couple things. I don't know why I would ever do this. In any operation that mutates a tensor in place is postfix with a... Okay, that's good to know. Yeah, I just don't know why I would do that, rather than like the more familiar syntax of this. That's good to know, though, that you can do that. I'm sure that's just what's happening behind the scenes. Standard Numpy-like indexing with all the bells and whistles. Yes! So good. Lots of tensor operations. NumPy bridge, converting... Ah. So that's how you get the NumPy array. So you got this y1 thing. And the type of y1 is this funky torch.float tensor. So if you say y1.numpy, then you get an actual array. And it's float 32. That's super cool. I dig. y1, is there like a d type? Dot type? There might be a way to change the type here. I assume there must be a way. See how the NumPy array changed? Wait. It's the same memory bound? Hang on. Back the fun bus up. Here's y1. I mean y1. Let's say y3 equals y1.numpy. Here's y3. And if I say y1 plus equals y2, so y1 is now this, y3 also changes. My mind is blown. Okay, so it doesn't make a copy. It just makes an array that points to whatever memory location is holding this array. So I definitely see how I could easily be burned by this several times if I want to pull out the NumPy array and use it for some other computation, then later I change the base PyTorch array. That could be real dangerous. That's something to be very wary of. All tensors on the CPU except the char tensors support converting NumPy and back. Okay. CUDA tensors. Torch.CUDA is available. Let's see what it says. Because it didn't look like it necessarily was. Okay. Cool. So I have to say do it in CUDA. What is x? x.CUDA. Okay. Oh, it tells me it's on GPU 0. It tells me which GPU it's on. That's nice. Not a super big deal. Comment from the audience. So much nicer than having to evaluate everything. Yeah, I 100% agree. I mean, like in Keras, it's super nice because it's very quick to set up the networks. But I just appreciate I don't have to type eval all the time. This seems very nice for interactive type work, where I'm going to be building up some wacky network of stuff. All right, you know what? Let's just try this. I want to see how this goes. Turn off my auto indent. There we go. So CUDA is available, so will be doing this. CUDA runtime error, invalid device. That's no good. Oh, well I did muck around. What is X? What is Y? X plus Y. Invalid device function. Now this could be because I've opened it multiple times, for example with the with Keras as well. It could be because I'm using my graphics card also on the desktop. Well, that's not a problem with Keras. So this is invalid device function. Let's do a quick search here. PyTorch invalid device function CUDA. No, I'm actually not necessarily searching just torch, but let's see what it says. Hey, what do you know? This is apparently a common torch problem. It might be that my graphics card is too old, which would be irritating, and that'd be a reason for me to continue to use Theano with Keras as the front end. Currently trying to run such and such model, yada yada yada. This person happens, they try to test the model. Huh. Math pairwise. Do I have the same problem? Is it math pairwise? Tensor math pointwise. Alright, so not exactly the same thing. Also, are the CU torch. Oh, this is not doing Python. Alright, but I want to see if it's the same kind of thing. 640M, I'm on 660. So this guy also has an older GPU. You do not have enough memory. That cannot possibly be my problem. I don't think so anyway. We can check NVIDIA-SMI. No, I have plenty of memory available. Almost all of it, in fact. So that's not the problem. Invalid device function. Wait a minute. This is not a directory on my computer. I think that's what the problem is. Whoever built this wheel file, whoever this person is, unfortunately, it seems there's still a couple hard links in there, in the wheel file for Python 3 CUDA 7.5 version. That's what I think is the problem, because this directory does not exist on my computer. Yes, ls/home/saumith does not exist. Okay, so that's definitely a problem. FYI to PyTorch developers, apparently your Python 3 pip installation version. Let's go back here. Your Python 3 pip 7.5 wheel has hard links to someone's local directory, whoever built it. So that's an unfortunate problem. So we're not going to be running things on the GPU with PyTorch right today, apparently. But this is something that should be able to be fixed relatively easily. I assume it works in some other version, and this is just not one that they tested extensively. That is unfortunate. It happens. Not happening today. Sad face. Okay. But let's see what we can do with the neural network stuff. You can still run it on a CPU. That's how I have to run TensorFlow. I can't use my GPU with that at all because my GPU is too old for that. Or rather, TensorFlow doesn't support legacy GPUs like Theano does. Probably because Theano is just an older thing. An older library. Okay, Autograd. Automatic differentiating. Yes, that's good. If you have some graph set up, then you can automatically compute the you can automatically take the derivative so that you can apply something like backpropagation. Autograd variable, central class of the package, yada yada yada. So you make a variable, so these are your weights. These are going to be like your weights functions. So let's do that. Bing. Torch.ones requires grad equals true. Alright, well, name variable is not defined. Oh, because I need to from torch.autograd import variable. Every time I see the word Autograd, though, I keep thinking like Petrograd or something, like a city in old Russia. Okay. So x, yes, is just a float tensor. And if I instead said rand, okay, one weird thing that I'm not a fan of. You can specify the size like this. It's just, multiple arguments. But I would much rather the size be specified as a tuple. And then it's clear. I guess I can do either. What other things can you do? Out equals none. Okay. I guess there's almost nothing else you can do. Huh. Fair enough. Fair enough, fair enough. Oh, I know an interesting question I have. I've got this y1 and y3. If I change y3, does that change put back into y1? I don't know, -5. It does. Okay, good. So whatever you're doing to initialize these variables, these tensors in PyTorch, you can always just initialize them in Numpy and then dump them, push them in. Like have a linked Numpy array. So that's pretty cool. Can I just say torch.tensor of, I don't know, numpy.ones, numpy.rand, random.random of 3,3. Is this something I can do? I love America, that's so good. So you can just pass in an array. That's good. I like it. I like it. But what if I say dtype equals numpy.float16? Ah. Interesting. I didn't know. Alright, well, whatever. We were not getting distracted by all this. So yes, you can make variables, things that are weights that you're going to be changing. So right now those are some random numbers. Can't do a none though, something that was pretty nice in TensorFlow. Another interesting point from our chat session today. Y.creator? Y was created as all as operation, so it was a creator. That's weird. Y1 was not. Okay. Let me say y equals x plus 1. Is that what we're doing? Lost track of this. X plus 2. Whatever. 1, 2, whatever. It's all the same. And apparently you can say y.creator. Okay. Oh, that points to like its parent node. Where did this come from? That makes sense. So add constant to this. So that is why this is x. I bet if I say x of 0, 0 equals, I don't know, 18. So that's x now. I bet y will have reflected this change to be 19 in the first position. Did not. So it did not reevaluate. It only evaluated when it created it. Is there like a remainder, resize? Is there like an eval? Okay, interesting. That's curious. Alright, so they're doing this stuff. They're creating another wacky variable using some slightly nonlinear things. So y times 3, and that's z. That's great. And then they want to take the mean. But z, oh, z is not just a number. Z is 4 numbers. So z.mean, if I could spell and type, there we go. Just averages those 4 numbers. So if I say z.sum divided by 4, you get the same thing. So this is that. This is an actual node declaring that, but I can look at it at the moment that I create it. What is z these days? Y times. So this is still just using whatever value happens to be in y at that moment. Out.backward is equivalent to doing out.backward torch.tensor. Leaf variable was used in place in an in-place operation. Alright, tell you what, let's redo this. Okay, now let's try that again. Alright, so I must have just forgotten to type something in there. is equivalent to doing prints gradient. So now I get things like x.grad. Interesting. Whereas things that are just sitting around before, if I say ZZ, hang on. If I say x2 is this, right, it knows no gradient because it's not used in anything. I see. But I can only take the automatic derivative with respect to a single, well, so far I've only learned how to do it with respect to a single node, but I might have multiple nodes I need to work. You only have sort of one output so far. So that's cool. So it sets the gradient there for you. So you just get the number. That's neat. And this is going to be 3, hang on, that's 3y squared. So 6y, based on whatever the y was. And that's just the same constant. Huh. Okay, cool. D out dx, yeah. You should have got a matrix of 4.5. Let's call the out variable O. We have, yes, 3xi squared. So yeah, you can do some simple chain rule stuff. Say that's 6 times xi times the derivative middle, which is just 1. Divided by, summed over all these c's. Question from the audience: can you do y3 equals numpy.copy y1.numpy to fix the issue with changes? That would probably work, yeah. So the question is, I've got this y1, I've got this y3 that are sort of irrevocably linked. If I didn't want to link them, I could do something like y3 equals numpy.copy of y1.numpy. And that'll just create a nice copy of the array. And so now that's y3. Now I have a separate set of memory for it. So if I say y3 of 0, 0 equals 100, 1000, whatever, that's y3, oh jeez, equals 10. The scientific notation was killing me. Versus y1, it's not been changed. So yeah, you just have to be careful about how you do that. But doing the copy essentially forces NumPy to make a copy of things. Literal, but it means you're using more memory. So if you got a big array and you say, hey, copy, you could get in trouble. Okay, well, that's cool. Right, so, some of this, but the derivative is, yeah, 3 halves. 2 comes down, whatever. You can do many crazy things with Autograd. Interesting. I'm just curious what this is about. They make a new random variable. I want to see what it says and then try to determine. I want to see the output and then try to determine what the heck the input meant. That'll be more fun for me, I think. All right, we haven't actually gotten any neural net stuff, and I'm a little concerned that if I have to handle the Autograd myself, that's going to be slightly more irritating than I really want to deal with. X.grad. So while y.data.norm, so we keep squaring this data. This could be dangerous. There we go. X.grad. So we made a variable that's 3 long. Oh, then we made a variable of the IC. So they created a random variable. Random 3 long tensor. They made it into a variable. They say y is just twice that. In y.data.norm. Y.data. What is y.data? Float tensor. So that's the actual, that's another shorthand to get the data itself, I guess. What is this? That's just regular float. Okay, cool. And so .norm. So what's the norm part? cfunc torch.norm. Okay, torch.norm. Returns the p-norm of the exponent value in the norm formulation. Returns the p-norm of each row after this. I feel like p-norm is not something you mean like the first norm, the second norm. Torch.norm a0, 1. Dimension, the dimension to reduce. Why do I feel like p-norm is... What is p-norm? Oh, well, it's in R. Oh, that's the probability. No, I don't think that's right. That's not what I want. I really don't think that's correct. Really? I mean, that's looking at the norm, jump to p-norm, jump to p-norm. No. Apologize that I have to look up some, we'll just note out some simple statistics. Interesting. Okay. So raise it to the pth power, sum all those things, and then take the pth root of it. For p equals 1, we get taxicab, Euclidean norm. Oh, okay. So like distance from the origin, in a sense. And what's the default? 1? The exponent, 2. The default is 2. So the default is Euclidean distance from the origin. Okay. That's fine. And the point is we keep making y bigger until its value is actually quite large. So why? Hey, what do you know? These are big numbers because we wanted the distance to be large. Then you take the gradients. Interesting. Why I got backward? Graph is differentiated using the chain rule. The variable is non-scalar. Yada 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 yada. The function addition requires specifying gradient. Variable is non-scalar and requires gradient. The function additionally requires specifying gradient. Should be a tensor matching type on location that contains the gradient of the differentiated function with respect to self. This function accumulates gradients and leaves. You might need to zero them before calling it. Okay. Gradient of the differentiated function is required only if the data has more than one element. I'm not fully following what that's doing. X.grad. I mean, it looks like it's just scaling the gradient for each of these variables is all. Each of these variables obviously has the same derivative with respect to dy dx is going to be the same for each tensor in here, or each scalar in this array. And so this is just scaling that gradient. So this is sort of like a learning rate kind of thing. Because that's 0.1, so that's that. That's 10 times as much, so 50 to 500, derp. And this is 1/10,000th of that. So just move the decimal places, that's all. Okay, so you can get the gradient of tensor type objects too, that's fine. Nothing too fancy about that. Neural networks. Yep, so they got a little, maybe they got a little font recognition or object or character recognition data. This graph is just drawn kind of strangely. I appreciate the inputs on the left and the outputs on the right. I prefer to put input at the top and output on the bottom, but I understand a lot of people do the exact opposite, which drives me crazy. Classified digit images. If you're classifying digit images, why do you have a picture of an A here? Not a big deal. Not a big deal. An NN module contains layers and a method forward input that returns the output. NN depends on Autograd. Okay, so they were just walking us through Autograd to get familiar with it. What do we got here? Fancy, fancy. I have to make a little net class to do this. This is not my ideal world. Let's see if I can get away without doing that. Nothing wrong with making a class. I just it's not as conducive to working interactively. Okay, so sure, we need some neural network stuff, we need some functional stuff. One for input image. And I guess there's no... So this is some convolutional layers, that's typical stuff. That's the number of channels. That's, what is this? 6 output channels. So, okay. Number of input channels, number of output channels, and you're forced to have a square kernel. Let's find out. Conv2d. Ding. I appreciate there's a little bit of a LaTeX right here. Unfortunately, Python does not render that. Kernel size, I bet if kernel size is a tuple, it'll do the right thing. Intertuple. Okay, so you can pass in whatever you want. What's the stride and padding default to? Stride equals 1, padding 0. Intertuple. 0 padding added to both sides of the input. Okay. Okay, so you can make sort of an arbitrary convolutional layer. And if I say 2, now I'm going to need, hang on. I just need to specify another layer where I'm going to have 6 kernels of input. I don't know, like what, 8 kernels of output or something? They say 16. All right, fine, 16. And 5 by 5s. Sure, I mean, these are just specifying like the layer weights or something. Well, not even. These are just specifying what those nodes are that create things. This is what, fully connected 1? Fully connected 1. But these aren't actually connected to each other yet. Note that I'm not passing conv1 into conv2 yet. I'm just specifying what these nodes are. Which is a little weird to me. Linear layer, right, that's normal. Or as they say, an affine operation. So wx plus b. And I'm betting this is the number of inputs, that's the number of outputs. So I do have to track how many inputs I have, which is my fundamental irritation. And why I love to use Keras. Because then I don't have to think about it anymore. I don't need to type that again. I don't have to change that again. 256, and then they're going to end up with 10. Yeah. Ah! There we go. And that'll be 3. There we go. I bet I can totally specify these out of order too. Shouldn't matter. Should not matter. Because I haven't connected them at all. So what does FC1 look like? Takes 400 things, gives you 120 things. What kind of things does it come with? Eval, forward, apply, children. Bound method of children. What kind of children doesn't it have? Apparently none. Alright. And they create 1 forward pass here. Oh, these are the activations. I see, so that's where they're worried about. Oh, gosh. And this is where they're building one big long sequence. So this is just like setup layer size. Setup layer sizes. We still have 10 minutes, so I think I can bust through this. Nope. Set indent. Ugh. No indent. No auto tab. Sorry, I'm trying to fix my... No tab, no smart tab. No, set paste, that's what I want. Just could not remember. So now when I paste things, it doesn't try to tab them all in and destroy me. So, it says, this first line here, says take whatever the first convolutional layer, this business, and do some 2x2 max pooling on it, and apply this rectified linear activation to it. Apply the rectified linear activation, then do 2x2 max pooling. Then x2, at the other part of x here, says apply the convolution to x, whatever x is. Have I had to set up x yet? I have not. So I'll need to define some kind of x thing here. Need to define x. X is going to have to be like some kind of input node or something. But then we define the activations over here. And I imagine if I really wanted to, I could just intersperse these with each other, so it's a little less goofy. I'll do some fully connected. There we go. And there we go. And there we go. Except all these self things need to go away, because we're not doing any class. Self, gone. Nope. Self, done. Needs to go away. There we go. Much better. I don't think I want to actually run that yet. Dumb flat features, because I need to figure out how to actually handle the inputs. All dimensions except the batch dimension. I mean, that's just adding up all the features. And all the layers for S and size. X size. I don't know what X is. Except the batch dimensions. Oh, this is the, I see, the 784 input features. Is that needed? That's needed here. I see. Alright, so that's a little function that I can define. That I can work with. So that's how they handle the automating that particular layer, the flattening. Although I wish I could just snap my fingers and flatten. It'd be nice. I don't need self anymore. Okay. So we'll just do that. Don't know why you yelled at me. Just do that again. Killing me, Smalls. You are killing me. Inconsistent use of. Oh, are there's... God. Did I lose? Somehow I lost... Somehow I lost some tabs and spaces here. That line, apparently, was made with tabs and not spaces. Much better. Okay, and again, I'm not making this a class, just because I want to be able to muck with my thing very quickly. Yes, I need an input thing. Do not name your inputs input. Terrible. It's bad, 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 bad. Input is already a function. For example, let's call it in1 or something. Doesn't matter. 32 by 32? What? Nobody uses 32. Nah, that can't be right. Cannot possibly be right. No, I think it's 28 by 28. That is what I think. They create net of input. Oh, net is the class type, which returns what? An n.module, I'm guessing? Is this baloney that I need? I think this is still... it's inherited some style of the original Torch about how they're specifying this thing. Like, well, let's make it into a class, and then we can do all this other stuff. That's not how I want to work. nn.module.net .capitalnet. I don't... I have a suspicion nn.module... That's different from nn.capital M module. .net. That's a thing? It's not a thing? Alright. I don't know what this is then. Why it's got super net there in it. That's strange. That might be a slight. Like, it's super of itself, but oh, it's right, whatever it's inheriting. So just an nn.module. My mistake. Base class for all neural network modules. Your modules should also subclass this class. I feel like I shouldn't have to subclass this class. I don't really want to put my... I don't really want to do that. So I'm going to try to avoid doing that. And if I get burned, I get burned. We have 5 minutes to figure this out. Seriously, the 32 is really mecking with me. Alright, so I'm going to definitely do 28 by 28. That's 100% what we're doing. Tell you what, let's put this over here. Just call this X. There we go. Let's see what happens when I do this. Oh, didn't like that. Did not like that. Didn't like that at all. Good there. Good there. Good there. That's fine. That's not so good. Size mismatch. 1 by 256 versus 400 by 120. Seems awful strange. Linear X. Oh, because my size is different now. This just seems strange. I just have 256 columns at this point? That doesn't make any sense. Does not make sense. Oh, well, I flatten. Right. X. By 4 by 4. Alright, fine. 4 by 4. Because I'm a little bit smaller. There we go. And module, and what do they do here? Of whatever my input variable is. So I guess I'm like forced to make a class anyway. Out equals net of input. This might be the deal breaker here. You know what? Let me just do this all again. All in one. Da 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 da. There we go. In one. Can I just do that? Can I get away with this? Nope. No, you cannot. You cannot do that. Out equals net input. That's strange. Oh, they're saying like out is the class, but I think X is the class here. So what is X right now? I'm gonna have 10 numbers. I just need a like sigmoid kind of activation. We are like basically out of time. But I still have, my watch says I still have a few minutes and I started slightly late anyway. So I bet I can do like this. I'm almost certain you can do something like this. If that's sigmoid of just X, probably? You think? Think you can get away with that? F dot, I knew it. There we go. Well, I don't need to do that then. They don't have, so they're just computing some numbers there? Alright. Net.zeroGrad. 0 is the gradient buffers of all parameters. Sure, let's just... ZeroGrad is not something I can do right now. That backward. Out.backward. Backprops with random gradients. Okay, sure. So if I say in one.grad, I get nothing. Alright. Conv1.grad has no attribute grad. X.grad. Out.grad. Alright, that seems not to be. Torch.NET only supports mini batches. Okay. Target. A dummy target, for example. Yeah, I appreciate that. As much as I would have liked to do a little bit of the silly stuff. Some like actual MNIST. Criterion. Okay, so these are also just nodes in the same sense. Oh, yeesh. Criterion. So mean squared error loss apparently is what. No, I don't want that. And then dot. Come on. Cross entropy loss. I assume that's categorical cross entropy. Cross entropy loss. Wait, what is output? Output equals net input. Out is just... They make another thing? Interesting. That I don't know. See if I can get away with this. Apparently I can. Loss. It's a cross entropy loss function. Follow loss in the back projection using this .creator attribute. Loss .creator. There's no attribute creator. Alright, so there's some things that are not working for me here. Because I chose not to try to put my neural net specification inside a Python class, because I didn't want to have to do that. I wanted to be able to just interactively screw around with my module. That was not working. So far, though, PyTorch has some really nice things in that it seems to support interactive use. However, you have to be careful. You can get burned if like parent variables, parent nodes change values. Their children may not immediately see those. And I'm not a fan of this having to put it in a class. I'm sure if I played with this long enough, I can get this to work. I do not know if I'm going to spend more time doing that. And I'm not surprised. They're doing the 32 by 32 here for a small image recognition set. And they go on to do more of this stuff. They show you the solution. Yeah. Okay, so that's a simple network, I guess. Still, I don't like separating my layer definitions from my activations, because then it becomes a pain to figure out which one goes with which. I suppose, oh yeah, this says conv1, but then they're like, oh, what's the size of conv1? I have to go back up here and look at it. To me, that's not ideal. I want it all in one location so that I can look at it and instantly see what's going on. I do give them credit, though. This is like easier to specify than Theano or TensorFlow, it looks like. It feels a little bit simpler. So that is nice. That's something to consider. And maybe it's worth taking another look at. I think right now I'm going to continue using Keras because it is just so convenient and simple to use. I am overdue to look at some, not skflow, but tflearn, some other high-level interfaces to TensorFlow. Also, the fact that the CUDA library was linking to someone's home directory, that's a problem. And because I just used pip, I don't think that was my fault. Alright, that's all I have tonight. So I want to thank everyone for coming out as we explore this new library. We might take another look at it, we might not. If you have an opinion on that, leave a comment, send me an email. And also, if you have something you think I should take a look at, hey, send me an email and we'll see if we can work something out. Alright, thanks again everyone. Don't forget, stay safe in the data mines.